Good morning, students. In this class we will continue with polynomials. Okay, before getting into this session, let us revise what we have discussed in the previous class. Okay, in the previous session you have learned what is polynomial and what are the types of polynomials, that is linear polynomial, quadratic polynomial, cubic polynomial, and what is the zero of a polynomial, isn't it? And geometrical method of zero of a polynomial, that is by using graphs. Okay, these are the things that you have learned in the last session. Now, in today's class, we will continue with that. Okay, see, in last class, you have learned one formula, isn't it, to calculate the zero of a linear polynomial. If you remember, you have a formula to calculate zero of a linear polynomial. Linear polynomial is in the sense the highest power is 1, isn't it? That is ax plus b. Isn't it? Here if you observe the highest power is 1. So it is linear polynomial. P of x is equal to ax plus b. If I take this as a quadratic, if I take this as a polynomial. Okay. So you have learned a formula to calculate the zero of a polynomial. Just recall, and I gave one example also. That is x is equal to minus b by a. Isn't it? X is equal to minus b by a. Here what is b? B is a constant term. B is constant and a is coefficient of x. So this is the formula to calculate the zero of a linear polynomial. And in this class, you are going to study about the formula to calculate the zero of a quadratic polynomial. Okay? Quadratic polynomial. Quadratic polynomial means the highest power will be 2. Okay? It is in the form of ax square plus p of x is equal to ax square plus bx plus c. This is the standard form of quadratic polynomial. Okay. Now, let me take one example and show you. P of x is equal to 2x square minus 8x plus 6. Okay. And children, in your next chapter, that is quadratic equations, that is chapter 10, you have learned how to find the factors of the given quadratic equation by using factorization, isn't it? That is by splitting the middle terms. You are now, by this time you might have learned quadratic equations thoroughly, isn't it? See, this is a quadratic equation, 2x square minus 8x plus 6. Okay. How will you find the roots of this quadratic equation? Now we have to find the roots of this quadratic equation. Okay, how do we do? Just recall quadratic equations chapter. What is it you have to do? You have to multiply. 2 into 6 is 12. It is plus 12. You have plus and plus. Okay. Now, when you take any two numbers and multiply, you should get 12. And you have to see this condition also, isn't it? Then you have to get 8 when you add or subtract those two numbers. Okay. If I take 6 and 2, it is 6 into 2 is 12. Okay, and minus into minus. Can I take 6 into 2x square? Yes, it is 2x square minus 8x plus 6. Okay, so it is 6 into 2. Minus into minus is plus, and minus 6 minus 2 is minus 8. Okay. 2x square. In place of 8x, can I replace that by 6x and 2x? It is same as this. Minus 8x is nothing but minus 6x and minus 2x, splitting the middle term. Okay. Now, if you take these two, what is the common term? You have 2x as the common. If you take 2x as the common, remaining is x minus 3. And here, if you take 2x as common, minus 2x if I take common, the remaining is 2x Now, what is the common term that you have in these two? X minus 3 is common. X minus 3 is common. If I take x minus 3 as common, what is remaining? It is 2x minus 2. Now equate this to 0. X minus 3 is equal to 0 and 2x minus 2 is equal to 0. From this, if I shift this to RHS, what happens? It becomes plus 3. So the value of x is equal to 3 and here 2x. If I take this to RHS side, it becomes plus 2. From this, x is equal to 2 by 2. That is equal to 1. You have got two values. So this 3 and 1. Okay. So what are the zeros of x? It is 3 and 1. If you substitute the value of x as 1 or 3 in this, you will get 0. Okay. Let us just cross check for your understanding. Okay. See, you already know that for linear polynomial, the number of zeros is 1. For quadratic, it is 2. And for cubic, it is 3. So, this is quadratic polynomial. You have got two zeros of the polynomial. First, I will take the value of x as 3 and I will substitute here. So, it is p of 3, which is equal to 2 into 3 square is 9 minus 8 into 3 plus 6. Okay, 9 into 2 is 18 minus 8 3 is 24 plus 6. 18 plus 6 is 24. 24 minus 24 is 0. We have got 0. P of x is equal to 0. When I take the value of x as 3. Now, if I take the value of x as 1, 2 into 1 square is 1 minus 8 into x is 1 plus 6. So, 2 minus 8 plus 6. 2 plus 6 is 8. 8 minus 8 is 0. We have got 0. Okay, hope you have understood. So, 3 and 1 are the zeros of this quadratic polynomial. Okay. Now, if you observe, x is 3 and 1. If I take the sum of zeros, these are the zeros, right? Sum of the zeros. That is 3 plus 1 divided by sum of the zeros as 3 plus 1. That is 4. Is it? 3 plus 1 is 4. Okay. 4 can I write it as minus of minus 8 by 2? Minus of minus 8 by 2. Sum of the zeros. Zeros are 3 and 1. 3 plus 1 will give you 4. 4 can be written as minus of minus 8 by 2. If you observe, minus of minus 8 is plus 8 by 2. 8 by 2 is 4. Okay. So 4 I have taken it as minus of minus 8 divided by 2. Why I have taken like that? Minus of, okay, minus 8. What is minus 8 here? Coefficient of x, isn't it? So it is coefficient of x. Okay. Now what is 2? Coefficient of x square, isn't it? It is coefficient of x square. Okay. In general, if I write sum of zeros in general form, if I write it as, what is coefficient of x? This is the general form, right? Coefficient of x is b. So it is minus b divided by coefficient of x square is a. So the formula is minus b by a for sum of the zeros. Okay. Next, I'll erase this. Okay. Next, product of zeros. Okay. Product of zeros means don't multiply 0 into 0. Okay. Zeros x square. Okay, in general form, what is the general form? Constant term is c divided by coefficient of x square is a. So product of zeros formula is c by a. So these are the two formulas. Sum of zeros is minus b by a. Product of zeros is c by a, where c is constant term, a is coefficient of x square. Here b is coefficient of x and a is coefficient of x square. Whereas in linear polynomial you had only one formula, that is ax plus b is equal to x plus b, whereas x is equal to minus b by a. Here you have two formulas, isn't it? One is minus b by a, the other one is c by a. You have to remember these two formulae. Okay? Now, just look at example 2 in your textbook. Example 2 in page number 11. Okay, find the zeros of the quadratic polynomial. What is it you have to find? Zeros of the quadratic polynomial x square plus 7x plus 10. Verify the relation between the zeros and the coefficients. First you have to find the zeros of the polynomial. Okay, and verify the relation between the zeros and the coefficients. Okay, what is the polynomial, quadratic polynomial they have given? X square plus 7x plus 10. Okay, first you have to find zeros, that is, first you have to find the roots. Okay, in quadratic form equations, we will call it as finding the roots, isn't it? Find the roots of the quadratic equation. Here they are telling, here we call it as zeros of the polynomial. Okay, how do you find out? Last term is 10, constant is 10. Okay, what are the factors for 10? 10 into 1 is 10, but you will not get 7. So I'll take 5 into 2. 5 2s are 10 and 5 plus 2 is 7. Okay. So x square plus 5x plus 2x plus 10, middle term, can written as 5 plus 2. Okay. X, if I take what is the common? X is the common term. So it is x plus 5. Here if I take 2 as common, x plus 5. Okay. Here what is the common term? X plus 5 is the common. Remaining is x plus 2. From this, equate both to 0. X plus 5 is equal to 0 and x plus 2 is equal to 0. From this, x is equal to minus 5 and x is equal to minus 2. So the zeros of the quadratic polynomial are minus 5 and minus 2. Okay, let us substitute this in the formula and see. Okay. So, what is the formula? Sum of zeros. That is verification. They are asked to verify, right? Verification. Sum of zeros is minus b by a minus, what is b in this? This is the equation given. What is b? 7 divided by, what is a? It is 1. So it is minus 7. Yeah, it is 7. So it is minus of 7 by 1. Sum of the zeros is nothing but, what is zeros? It is minus 5 plus of minus 2. Sum is addition. Minus 5 plus of minus 2 is minus 5. Plus into minus is minus 2. Minus 7. Did you got same value? If I add these two, minus 5 and minus 2, and if I directly write or not? Okay, by applying formula. See, instead of doing this, directly you can tell what are the zeros of the quadratic polynomial. Okay, only when they ask, you have to use direct method, that is applying the formula. Next, if you look at example 3 in your textbook, find the zeros of the polynomial x square minus 3 and verify the relation between the zeros and the coefficients. Okay, here the polynomial is x square minus 3. Okay, how will you find the roots? So x square minus 3 is equal to 0, isn't it? From this x square, if I take this to this side, what happens? It becomes plus 3. X square is 3. What is x square? X is square root of 3, isn't it? X square is 3. From this, x is equal to plus or minus root 3. Okay. So sum of the zeros, you have got two values. That is x is equal to plus 3 and x is plus root 3 and x is equal to minus root 3. Okay, sum of zeros. Sum of the zeros is root 3 plus or minus root 3. That is root 3 minus root 3. You will get zeros. 0. Sum of zeros you will get 0. If I use formula, what is the formula? Sum of the zeros minus b by a. Minus b is here. Do you have b? If you compare this with standard form ax square plus bx plus c, do you have b here? No. It is ax square minus c, isn't it? So b value is 0. 0 by anything is 0 only, right? So our answer is correct. Okay, next, product of zeros. That is root 3 into minus root 3. Isn't it? Plus root 3 into minus root 3. Plus into minus is minus root 3 square. So it is minus root 3. What is the formula? C by a. What is c? C is minus 3. What is a? 1. Got? So your answer is correct. Okay, hope you have understood, children. Now look at example 4 in page number 12. Find a quadratic polynomial. The sum and product of whose zeros are minus 3 and 2 respectively. In this question, they have given the zeros, that is roots. Okay, minus 3 and 2. So the zeros of the polynomial are minus 3 and 2. You have to form the quadratic polynomial. Okay, you have to frame the quadratic equation. It is similar to quadratic equations only. Okay, little. Okay. Now, so the zeros are minus 3 and minus 2. You have to write that in standard form. That is ax square plus bx plus c. You have to frame the quadratic polynomial. Okay. You know that. So this is the quadratic polynomial standard form. Ax square plus bx plus c is equal to 0. Minus 3 and minus 2 are the zeros of the polynomial. Okay. Now, first take sum of zeros. Okay. Sum of zeros is minus 3 plus 2. That is equal to minus 1. Okay. Next, product of zeros. See the sum and the product of zeros. The sum is -3, they are already given, and product is 2. Okay, it is 2. So that is minus b by a is -3 and c by a is equal to 2. Okay. From this, if you observe, what is a? Do you have anything here? A is 1 when you compare. A is 1. What is b? Minus b is -3. B is 3. And what is c? It is 2. Now, write this in standard form. Ax square. Ax square is 1x square. Isn't it? Plus bx. B is 3. 3x. Plus c is 2. So, the equation is the quadratic polynomial is x square plus 3x plus 2. Okay, this is how you have to do. Okay. Next. Now moving on to the exercise problems, that is exercise 9.2 in your textbook. Find the zeros of the following quadratic polynomials and verify the relation between the zeros and the coefficients. Okay. You have to find the zeros. Then you have to verify by using the formula. If I take the first question, x square minus 2x minus 8. Okay. How will you find the roots? That is, how will you find the zeros? Last term is -8. So it is 4 2s are 8. Isn't it? So -4 plus 2. -4 plus 2 is -2 and -4 into plus 2 is -8. Both the conditions are satisfied. Okay. Now, -2x can be written as -4x plus 2x. Okay. Now, take these two terms. Which is the common? X is the common. So, remaining is x minus 4. Here, if I take 2 as common, x minus 4. Okay. So, in these two, which is the common? X minus 4 is common. If I take x minus 4 as common, what is remaining here? X. Here, what is remaining? 2. Okay, now equate both of these to 0. X minus 4 is equal to 0 and x plus 2 is equal to 0. From this, x is equal to 4 and x is equal to minus 2. So, 4 and minus 2 are the zeros of this polynomial. Let us just cross check. Okay, verify. How will you verify? Sum of zeros is minus b by a. Isn't it? Minus, what is b? 2 by a is 1. Did you get -2? Yes. So this is correct. Next, product of zeros. It is c by a. What is c? -8. A is 1. Let's see by a. Product of zeros is c by a. Is the equation correct? X square minus 2x minus 8. Yeah, it is correct. Only one is correct. The other one we should get -8, but I am getting 4. Where did I miss? 8 can be replaced as 4 plus 8. Minus 4 plus 2 plus 2 into it's minus 4. So it is minus b by a, this is 2 by a. -2 and 4. Right, it's correct, right? Product of the zeros is c by 8. -8 by 1. Verify the relation between the zeros and the coefficients. Let us look at one example. Constant term divided by coefficient of x squared. Yeah. sorry. Directly I have it. That is a mistake. Sum of zeros means whatever the answer that you have got. That is 4 plus minus 2. That is 4. 4 minus 2 is 2. 2 divided by 1. Here product of zeros. Product of zeros, that is 4 into minus 2. That is minus 8. Isn't it? So now product of zeros is 4 into 2 is minus 8. Minus 8 and minus 8, same answer. Okay. So your answer is correct. Okay. So now moving on to the second question. 4s square minus 4s plus 1. So here the polynomial 4s square minus 4s plus 1 as variable s. It is in terms of s, not x. Okay. So 4s square minus 4s plus 1. It is p of s, isn't it? It is p of s, not p of x. So how will you find the roots? That is how will you find the zeros? So multiply first and last term. 4 into 1 is 4. Okay. Now what are the roots? 2 2s are 4. Minus 2 is minus 4. Minus 2 minus is plus 2. Okay. 4s square minus 2s minus 2s plus 1. Okay. Now what is the common? 2s is common. So remainder is 2s minus 1. Here nothing is common. I take it as 1. I take 1 as common. Okay. So remaining is 2s minus 1. So in these two, what is common? 2s minus 1 is common. Remainder is 2s minus 1. Equate each of these to 0. 2s minus 1 is equal to 0 and 2s minus 1 is equal to 0. From this, 2s is equal to plus 1. S is equal to 1 by 2. Here also, 2s is equal to 1. S is equal to 1 by 2. So, both are same. Isn't it? Now, sum of the zeros. Sum is equal to 1 by 2 plus 1 by 2. That is 1. Isn't it? So, what is the formula? Minus b by a. 1 is equal to minus of, what is b? B is coefficient of, yes, that is 4. A is 4. Sorry, it is minus 4, right? So 4 get cancelled, it is plus 1. 1 is equal to 1. So your answer is correct. You can check with product also. Product is equal to 1 by 2 into 1 by 2. Isn't it? So it is 1 by 4. And what is the formula? C by A. C is 1. A is 4. 1 by 4 is equal to 1 by 4. Yes, so your answer is right. Similarly, take the third problem as homework. Fourth one I will do, and fifth, sixth you take it as homework. Okay. See, fifth problem is similar to the example problem which you have done. That is x square minus 3, example 3. Fifth problem is similar to example 3. Okay, do it by yourself. So the homework is exercise 9.2. Third question. Fourth, third, fifth, and sixth. Okay. Fourth one. Here p of u is equal to 4u square plus 8u. Okay. How will you find? If I take 4u as common from these two, 4u as common, it is u plus 8 is equal to 0. Isn't it? So from this u plus 8 is equal to, if I take this to RHS, what happens? It is in multiplication form, right? If I take it, it comes to division form. 0 by 4 by u. That is 0 only. So u plus 8 is equal to 0. From this u is equal to minus 8. Okay. So you have got only 1 root, that is 1 0. 6 9 1 2. We'll check. 4 if I take it as common, that is u plus, oh sorry. If I take 4 as common, the remainder is 2, right? 4 into 2 is 8. So it is 2, u plus 2. It is also 2. So 1 is 2, okay? Hope you have understood, children. 4u square plus 8u. Okay, I have taken 4 as common and u is also common. Isn't it? If I take 4u as common, what is remaining? U plus 2. Okay? Now, if I shift this to this side, what happens? 0 by 4u. 0 by 4u is 0 only. U plus 2. From if I shift this plus 2 to this side, it becomes minus 2. So 1 0 is minus 2. 1 root. What will be the other? No, it is 0. Okay? So if you cross check, sum is equal to minus 2 plus 0. It is equal to minus 2. And formula is minus b by a. Minus b is 8. A is 4. 4 ones are 4 twos are. So your answer is correct. And product is minus 2 into 0 is 0. Formula is c by a. C is 0 not c, right? 0 by 0 is 0. So your answer is correct. Okay? Hope you have understood, children. Same way, try to do the third, fifth and sixth problems. Second way, find a quadratic polynomial each with the given numbers as the sum and product of its zeros respectively. Okay? So, in this main they have given the zeros already. You have to write a quadratic polynomial. You have to frame a quadratic polynomial. Okay? I have done one example problem on this method. So, we will see. So it is 1 by 4 and minus 1. What is sum? Sum is 1 by 4. Sum is 1 by 4 and product is minus 1. What is sum? Sum is minus b by a and product is c by a. Isn't it? So children, I will learn this one. Ax square plus bx plus c. This is the standard form of the quadratic equation, isn't it? So this can be written as k into x squared minus k into alpha plus beta x plus k into alpha beta. Okay. Now, what is k? K is a constant. Okay, here k can be written as real number. K can be taken as real number. Okay, this is same as this. If you observe, what is the value of a? It is just k. What about b? It is k into alpha plus beta. What about c? It is k alpha beta. Okay. From this, if you observe, a is k and b is minus of k into alpha plus beta, c is equal to k into alpha beta. Okay. So from this alpha is minus b by a and alpha into beta is equal to c by a. Okay. Alpha plus beta, say ax square plus bx plus c is equal to 0. That is the quadratic polynomial you already know. See here, what I have taken is a is the ax square plus bx plus c is equal to 0 as kx square minus k. It is also the general form. Okay, kx square minus k into alpha plus beta x plus k alpha beta. Okay, where k is a real number and the value of a is k. Okay, a is k and b is minus k into alpha plus beta. From this, alpha plus beta is equal to, if I take this k to this side, it comes to denominator, isn't it? Alpha plus beta is equal to b by minus k. Okay, from this, alpha plus beta is equal to b by minus k. But you know that k is equal to a, isn't it? So replace k by a. You will get minus b by a. Understood how you have got this? And here, c is equal to k into alpha beta. From this, alpha into beta is equal to c by k. Alpha into beta is equal to c by k. But what is the value of k? A. Isn't it? Alpha into beta is equal to c by a. Okay. Now, what is it you have here? Minus b by a. What is minus b by a? It is alpha plus beta. And what is c by a? It is alpha into beta. Okay. Hope you have understood, children. Minus b by a is alpha plus beta and c by a is alpha into beta. Okay. So if I substitute there, kx square minus k into alpha plus beta is constant term divided by coefficient of square term. Sorry children, I got confused. Okay children, we will discuss about this in the later class, quadratic polynomials. We will stop up to here. Okay, so this is the homework problems, 3rd, 5th and 6th problem. You take it as homework. This we will continue in the next class. Okay, so this is little confusing. I will find out an easy way for you to understand. Okay, so try to do these problems, that is 3rd, 5th and 6th. And so still if you have any confusions in quadratic polynomials, then you have to look at quadratic equations chapter. Okay, then it would be easy for you to solve quadratic polynomials. Okay, see you in the next class children. I will find out the easiest method for that. Thank you children.